You tell me when I shall start.
Sir,
Hello?
the session has already started, sir. You can start, sir.
Oh, okay. Now, welcome back to the live session. This is the second and considered the second and third live session of the NPTEL course on industrial biotechnology. Uh, I hope you are enjoying the course, and today this is a opportunity to clarify some of the points, some of the questions, some of the queries that we have. And initially, I shall take the question that whatever has been communicated to us, and then I shall, if you have any other question, then we can do it in the we can use the chat box. Okay. So first, let me go to that question that is already asked. So, is it? I hope it is okay. No, that visible. Harshita, is it visible?
Yes, sir.
Okay, no problem.
Yes.
Okay, the first question that asks that what is saline suspension,
It's
or
visible,
how?
sir.
Okay, what is saline suspension and how it is used to keep the organism active? This question was asked by Diksha Day. Now, let me tell you that saline, it is not saline suspension, it is saline solution. Because how we prepare the saline solution? By making this sodium chloride solution. Sodium, we know the sodium chloride is soluble in water. And the saline solution is prepared by using the concentration 0.85% weight by volume. That means how much? That means 0.85 grams of sodium chloride per 100 milliliter of the solution. We make a solution and then we sterile, and in that we prepare the cell culture. Now, question is very important that how the why how the organism remain active here. Now, as you might be knowing that microorganism inside they have that cytoplasm, that they have this some kind of osmotic pressure. So when you prepared any kind of cell suspension, it is necessary to prepare the cell suspension in such a way so that the osmotic pressure that we have in the solution will be same as that of your cytoplasm layer that we have inside the cells. So it has been found that if you prepare 0.585% saline water, that will be something similar with that. Am I right? So that is the reason why we prepared 0.85% saline water. So so we have written the answer like this: the saline water is of the solution of 0.85% weight by volume sodium chloride in water. It helps in maintaining the uh, osmolarity of the microbial cells, thus minimize the chance of cell death and keep the cell in the active conditions. So this is very simple. So I hope you understand that. The next question that is asked, and it might be due to this the same student, he asked this question, that is why the cytosine and cytosine thymine dimer formation are less prevalent in non-ionizing radiation. So so this is the, you might be knowing that mutation is a very important aspect for strain development, and this is done with the help of a certain treatment. And one of the important treatment is the radiation. So we have two type of radiation. One is the ionizing radiation, and another is non-ionizing radiation. Now this is non-ionizing radiation, and examples of that That is the ultraviolet radiation, what we call UV radiation. Now, now what happens in case of non-ionizing radiation, that there is absorbed by a double bond of thymine and cytosine bases in DNA. So thymine and cytosine present in the that DNA, and this added energy open up the bond and allow it to react with the adjacent base. And if the neighboring base is enough thymine or cytosine base, it can form a covalent bond. It can form a covalent bond between the two bases and could result in a thymine dimer, thymine dimers, and thymine cytosine dimer or cytosine cytosine dimers. And however, the dimer formation occurs most frequently between the adjacent thymine residue on the same DNA strand, whereas the cytosine based DNA undergoes the hydrolytic deamination, that is, the get converted into the uracils at a considerable rate when UV radiation is induced formation of pyrimidine dimers. So this is kind of explanation for you have. The main purpose is that this dimer formation that makes the organism little bit inactive. I wonder the DNA will be little inactive. So characteristics of the organism will be changed. That is the main purpose of this radiation. I hope you will get the answer. The next question that is same student asks, and this is a very vital question. That is the what do you mean by that water footprint? And this is a very good question. The water footprint it deals with the utilization of water. That how much water you are using for producing some kind of product or utilizing some kind of product, that is very important. So that and water is very vital, as you know, it is very vital. So here you can see that water footprint serve as an indicator of total fresh water use, both directly and indirectly, by a consumer or producer. It is measured in terms of total volume of water consumed or or polluted per unit time. So that this is very important. That that how much water is. If you use the less water, that means that is good. If you use more water, it is not good. That means you are utilizing a lot of water. The water footprint could measure the amount of water required to produce all the goods and services consumed by any individual human, a whole household, a business, or by an entire nation. Thus, this parameter can help to represent the water use pattern at different level from individual to the entire country. Now, water footprint that plays very important role in the reason is that if this is less, then that is more encouraging as compared to if it is more. So this is what I want to communicate to you. Now another question. His name is Nandar. He asks about one video, that lecture number 6. Can you please explain the fermentation process uh, of any briefly, as we are chemical engineers? So very good, very good. That I am. You are most welcome as a chemical engineer that you are attending this course. Now let me give you very brief introduction between the biochemical process and chemical process. Though in my lectures or in my videos, this has been clearly stated. Now, in the chemical process, what is happening that you are taking the substrate in a vessel. You know how in a vessel how you define the reactor. Reactor is kind of vessel where you take the substrate and allow the reaction to take place. Am I right? Now, Now that is the chemical you are putting and allow it to react. Then you are taking out the product. Suppose A reacts to give B. That is very simple reaction that we have. Now biological system, what is happening, that they are also using substrate, but the problem is that there we are using some biological component. Now this biological component, not necessarily it should be the living cells, it may be the enzymes. They are not living cells, they are there, but they are formed in the living cells. They are the living cells are the source of enzymes, because inside the living cells, what are the living cells we have? We have microbial cells, we have plant cells, we have animal cells. So different type of cells we have, living cells are there. So all these living cells, we have different type of enzyme. Now if you take out those enzymes, allow it to react in a vessel, then we call it that biochemical reactions. But you are talking about the basic difference between the fermentation process and what do you mean by fermentation process? Basically, we deals with some kind of microorganism. The speciality of the biochemical process as compared to the chemical process, that most of the chemical process that usually operated at high temperature and high pressure, am I right? And where the fermentation process usually operated at the ambient temperature and atmospheric pressure. So energy point of view, if you look, the fermentation process is more attractive as compared to the chemical process. I hope you understand that. And second factor is very important, where I think you get more your answer. That in case of chemical process, as your product changes, your raw materials also changes. If your product is complicated, your raw materials also complicated. If you look at your chemical process, you will find. But a fermentation process or biochemical process is something different. But the same compound, as for example sugar, can produce n number of products. And sugar can produce citric acid, sugar can produce lactic acid, sugar can produce acetic acid, sugar can produce itaconic acid. So now what we shall have to do? We shall have to only change the microorganism. Different microorganism has different properties. When we add this microorganism in this particular that media, then we get different type of products. We get the penicillin, different products we have. So we have written the answer in in this way. In this part of video, the materials of you're talking about the materials of construction of the reactor. That is also very important. As you know, that in the fermentation industry, the material of construction is mostly the stainless steel. Now, as far as stainless steel is concerned, that there are different type of stainless steels is marketed. One is SS304, SS314, SS316, SS317. Different types of stainless steel. As per your requirement, you can do that. Now, in the fermentation industry or biochemical industry, if you look the metabolic pathway, mostly it produces the organic acid. So it is some kind of corrosive in nature. So naturally, we use the special type of stainless steel in the biochemical industry. Mostly we use SS316, whereas in the chemical industry, we use SS314. Now, in case of chemical reactor, we also use the mild steel. When we use the mild steel, then we shall use some kind of coating material, and one important coating material, epoxy resin or glass coating. So that makes a barrier of your product or substrate with this construction material of construction, so that it will not directly, your material of construction will not directly affect uh, by the by your product or the substrate concentration. So it has been written like this in this part of video. Materials of construction of the reactor has been explained. In case of mild steel reactor, the coating of glass or epoxy has been done for prevention of the corrosion. And why the corrosion is taking place? Maybe several reasons, maybe acid, maybe H2S, there are so many types of reasons that we have. It has been observed that presence of sulfide in the reaction liquid leads to corrosion, especially in acidic environment. To prevent this, an anti-corrosive coating is required, which can act as a barrier between the reaction liquid and the material of reaction. The fermentation can be defined in many ways. As the biochemistry takes, it is generally the energy by the catabolism of the organic compounds, and industrial biotechnology concept is the process of product generation by mass of culture of microorganisms. So that is, I already explained the beauty of this process, that you cannot find that in the chemical process the same substrate you cannot produce the n number of products. As your product changes, your substrate changes. But the biochemical process or fermentation process is totally different. Same substrate can produce n number of products. I hope you understand that. Now another student asks a very simple question: what is dilution rate? Let me explain this. What do you mean by dilution rate? Initially, you can recall. I tried to discuss that the reactor analysis. Right, reactor analysis. We have come across two type of process. One is batch process and the continuous process. Now, dilution rate is applicable in the continuous process. In the continuous process, you are continuously passing some volume of the liquid to the fermenter. Am I right? Volume of the liquid to the fermenter. Let me take the pen. Okay. So that here you see that that this is the media flow rate. It's suppose some is entering here, and this is the reactor. Am I right? And this is going out. That means this is the inflow, and this is the outflow, and this is the volume of the reactor. This is the volume of the reactor that we have. Now interestingly, that question that me asks you, how long this liquid resides in the reactor, and but now why it is important? The important is that the time the liquid resides in the reactor we can consider as the time of reaction. Am I right? And which is very vital for any kind of chemical reaction or biochemical reactions. Now, in the chemical process, we have a term called hydraulic retention time. What is hydraulic retention time? Is V by F. Am I right? V is this working volume of the reactor. What is working volume? Working volume is nothing but this is the liquid volume. This liquid volume is considered as the working volume. This is V by F. This is we consider this is the hydraulic retention time. Am I right? Hydraulic retention time. So it is not coming properly. So anyhow, that this is the hydraulic retention time that we have. Now, if you write in a reverse way, F by V, then what will happen for the hydraulic retention time? What will be the unit? This will be unit as time. Am I right? Maybe time will be in hour, maybe in minutes like this, or maybe in days. But 1 by V, if you write F by V, F by V will be what? F by V, the unit will be time inverse. Now this is called dilution rate. The 1 by D is equal to hydraulic retention time. Now why we take this dilution rate? That means that because in a particular reactor V is constant, V is the working volume of the reactor. Am I right? So if you want to change the D, what you have to do, you have to change the flow rate, volumetric flow rate. So you just change the volumetric flow rate, then you can change the value of D. So at different dilution rate, you can find out the characteristics of this system. So dilution rate, so we have written like this: the dilution rate is the rate at which the phase media is added into the reactor for maintaining the growth of the microorganism, and it can be calculated by the flow rate of the media by the working volume of the reactor, what I told you. So, for example, uh, there is a reactor 1 liter here in this problem, 1 liter reactor, and flow rate is 10 100 milliliter per hour. Now if you divide, then the dilution rate will be zero point 0.1 or inverse. So this I hope you understand. And the beauty of the continuous process is that if you operate at a particular dilution rate at an infinite time, it is possible to attain the steady state condition. What is not possible in case of batch process. Now, what is steady state condition? Steady state condition means when there is a no alternation, no change in the concentration of the different component present in the reaction mixture. Suppose in this reaction mixture, you have cell mass, you have substrate, you have product. Now, if those concentration in the cell mass, you are continuously passing your substrate here and taking out the product, and but under when it reaches the steady state condition, then cell mass concentration, product concentration, and the substrate concentration, that will be uniform, that will be given unchanged with respect to time. This is the beauty of using this continuous system. Another important feature of this continuous system is that d equal to mu, because if you look at the chemostat, d equal to mu, because if you look at the life cycle of the cells, we have lag phase, we have log phase, we have stationary phase, we have the decline phase. Now every phase has its own significance. And suppose we want to produce Baker cyst. And what is the purpose of the Baker cyst? That is used in the bread making industry, largely used in the bread making industry, because now the Baker's is kind of cell mass. So if you want to increase the cell mass production, so you know the maximum cell mass growth take place in the log phase. What is log phase? Log phase is the exponential growth phase. So if the log phase you have particular mu, what is mu? Mu is the specific growth rate. I told you under steady state condition, mu is equal to d. So if you maintain the same mu, that the dilution rate in such a way, the maximum growth of the cells take place, you will get the maximum amount of cell mass in your system. I hope you understand that. Next question was with the enzymatic reaction kinetics. The question is how the unfolding of the bioenzyme will lead to steeper curve. So I think this question asks that regarding the denaturation of the enzyme during the during the heating process. This is, I think, this is a good question. And so that so enzymes, how you define enzymes? Enzymes are basically protein molecules, but not necessarily all enzymes are protein. Some a few enzymes, they can be produced synthetically also, but mostly the enzymes, they are protein in nature. And but question comes, what kind of protein? This is considered as a that one is fibrous protein, another is that globular protein. And globular protein is kind of fibrous protein. Your hair is a fibrous protein, is a keratin. But globular protein is kind of, if you look at hair, it is a straight line. It is just a kind of kind of fiber type of material. But, but globular protein is something different. Globular protein, they have the randomly folded structure. And question come, why this folding occurs? Due to the hydrogen bonding. And this hydrogen bonding will be between the carboxylic and the amino group of the of the different protein molecules with the R groups of the different amino acids. So this is how the folding takes place. When they randomly fold, a particular site is exposed whose configuration has disimbalance with the configuration of the substrate and which is considered as the active site. Am I right? Now, so the active site of the enzymes plays very important role for its activity. So if the active site is lost, then your enzyme will lose the activity. Now when you heat the enzyme, what will happen? So, but the hydrogen bond is they have a they are not very strong bond. There might be their force of attraction might be 7 kilocals per mole. So if you keep on hitting this, so you are putting more energy to the system, and if you keep on increasing giving the energy to the system, then what will a time will come, then things will be neutralized. And when neutralizes the force of attraction due to hydrogen bonding, then the bonding will be becoming loosened, and when it's loosened, then it will be unfolded. The structure will be unfolded. Now, as soon as the protein is unfolded, as the protein loss is active site, and as is lost the active site, then the your curve will be steeper. Let me explain like this. At the bottom, if you see that, I hope you are talking about the Arrhenius equation, am I right? So what we have plotted, what is the equation that we have? We have k equal to a into e to the power a into r into a by t. Am I right? So our plot is 1 by t. This t is Kelvin. Am I right? And this is with respect to k, ln k. If you have, this is ln k. So if you have this plot, so it is like this. It is as you increase temperature means 1 by t decreases. And then what I'm saying that it is sharply fall down, because in case of inorganic catalyst, this fall is like this. It is not sharp. But in case of enzyme, it falls sharp. Why it falls sharp? Because when you increase, then your activity increases. Why the activity increases? Because as you put some energy, the bond try to the the hydrogen bond try to open up. So there will be some kind of oscillation movement at the active site of the enzyme molecule. And due to this oscillation movement, more substrate molecule will be attracted towards the active site, and that is how the rate of reaction that will increase. But when you give more energy to the system, then your structure will be totally unfold, and then what will happen? The activity will be totally lost. Then there will be sharp fall. You can see that the sharp fall, and this is not happen in case of inorganic catalysts like platinum, palladium, nickel. That is not there. There also it happens that decreases after some temperature, but this fall will not be this sharp as compared to the enzymatic reaction. So what we have written, the unfolding of enzyme will lead to the steeper curve as compared to inorganic chemical catalyst. Enzymes are the protein molecule with complex three-dimensional structure which helps in promoting the biochemical reactions in the living system. That we know, all we know. Now, three-dimensional structure of the enzyme is very crucial for its activity. Am I right? Without active site, the protein without active site is not an enzyme. Protein with active site, we call it enzyme. Am I right? Now, if the enzyme structure changes due to the external factors such as change of temperature or pH of the solution, it leads to a significant change in the enzyme activity. Since it is the biomolecules, it is more sensitive to the environment as compared to the chemical catalyst. Slight changes in temperature lead to unfolding of enzyme structure, which causes loss or reduction of enzyme activity. Therefore, in the case of enzyme, that when the temperature increases, the curve of Arrhenius equation becomes stiffer, as compared to chemical catalyst. I hope it is very clear to you. It's not very difficult. In case you have a problem, please consult my book, because I have we have written one book, Biochemical Engineering, introductory textbook published by Jenny Stanford Publishing, Singapore. So marketed by CRC Press. So you please go through this book, or you can go through Lebensfeld, so you can understand this very well. Okay. Now, next question that is asked, can I get the simple description of the falling film evaporator? I don't know the the background of the student who has asked the question. If the chemical engineering student, I hope you understand that the evaporator is the main purpose is to concentrate the liquid. Am I right? You are evaporating the moisture. You are taking out the water molecule from the mixture. So so you know that why you do that. Question comes, why you do that? Because when suppose we know that boiler tubes, we have seen that boiler tubes is used for what purpose? We know that steam generation purpose. That and most of the biochemical industry, we require the live stream. Why we require the live stream? To maintain the sterility of the fermentation process, because everywhere we require stream, because whenever we whenever we add some kind of seed culture to the inoculum vessel, all pipelines should be sterilized with the help of live stream. You know that, so that is very important. So the question comes that what is falling film evaporator? Yeah, our answer is that, I hope this answer is quite well written, that evaporators are special type of heat exchanger. You know what is called heat exchanger? Where we transfer the heat. So we have one heating element, and that transferred the heat to the liquid where we want to heat it. And how the transfer of heat takes place due to conduction, convection, and radiation, and used to concentrate the solution. Am I right? Now, falling film evaporator are the type of long tube vertical evaporator. It is a long tube vertical evaporator. Am I right? In which the feed is added from the top of the tube and flow down by the action of gravity. This is very important. The tube, it is it is falling in a downward movement. That is why falling. They're saying falling film. This is downward, and to maintain the uniform distribution of the liquid in the tube, a spray nozzle or the distributor is used. While moving the downward liquid form a thin continuous film inside the tube and flow at the boiling point, leading to evaporation of the liquid. The concentrated liquid gets collected at the bottom of the tube, and vapors go to the separator, or vapor usually go on the top. Am I right? So that in the separator also concentrate the liquid collected uh, in the bottom, or goes out from the top, and steam is is generally used for heating the tube. In falling film evaporator, heat sensitive components such as the orange juice can be concentrated. Falling film evaporator can handle more viscous liquid as compared to rising film evaporator. For details, you can go through this link. You can find the detailed information. This is largely used in the chemical industry, also in the food industry, or it's largely used. So falling film evaporator is a very important heat exchanger that is used for the evaporation of the liquid. Okay. Now, next question asked by Isita, that is one student, on the stoichiometry of the bioprocess. And that hard question is that I don't know what is the question, but then maybe that B is so C might have asked this question that regarding the coefficient. Am I right? That how the coefficient can be calculated, because when you write a equation that that A plus B gives C plus D. So A has some coefficient, maybe A has a coefficient XA, and Y has a B has a coefficient Y, and C has a coefficient Y Z, and like this, different coefficient is there. So C has a might be having the question that how this coefficient correlated can be calculated, and this is the respect to one particular problem. I, thank you. This it is better if I go to the video, we go to the that PPT. So this particular problem, let me start from the beginning, from this point of what this problem deals with. That anaerobic digestion process. What is anaerobic digestion process? What is anaerobic? Anaerobic means when because microbial microorganisms, they usually work into to maybe classified in two different types. One is called aerobes, another is called anaerobes. The aerobes means what? That they require the oxygen for their growth and metabolism. The one thing you should remember, the oxygen that microorganism that is used, that should remain in the dissolved condition in the media. And so that not like human beings, that we can use the oxygen that present in the air, but microorganism cannot use the oxygen from the air. They can take the oxygen which is present in the dissolve in the media. Okay, I hope you understand that. Now the thing is that uh, that anaerobic process usually take place in absence of oxygen. So this is easy to operate. Now, advantage of the anaerobic process is that because it has one important process is the anaerobic digestion process, where the organic waste can be converted to methane and carbon dioxide. So this problem deals with the one organic waste, how it is converted to methane and carbon dioxide, and you have to find out the coefficient of different coefficient in the reaction mixture. So one particular parameters that we have yp by s. What is yp by s? We consider this yp by s we consider as a that product yield. Product yield means gram of product per gram of substrate consumed. This product yield means gram of product per gram of suppose you have substrate here, and this substrate is converted to methane and carbon dioxide. You know that you have methane. Sorry, it is not coming properly. It is methane and carbon dioxide. And what is carbon dioxide? Carbon dioxide is your product. This is carbon dioxide is your product. This is P. Main product is the carbon dioxide. So that y p by s, a gram of methane produced per gram of substrate might be your kind of organic material, and gram of substrate that is utilized, not gram of substrate added. You should remember two things are there. One is amount of substrate that is added, and amount of substrate that is utilized. Now this A stands for gram of substrate that is utilized. So Yp by S is equal to gram of product form per gram of substrate utilized. Am I right? Now the this is equal to epsilon p into sigma s, gamma s, sigma p, and gamma p. This you know that during stoichiometry, and this is called degree of reduction of substrate, degree of reduction of product, and this you have already done that. Now, when we use this, this can be we can easily find out from the empirical from the this empirical formula of the particular component present in the reaction mixture. Now, once you calculate all this thing, and we know epsilon p, the thermodynamic efficiency, thermochemical efficiency of the anaerobic digestion process is about zero point 0.7. Am I right? And for aerobic process is zero point 0.5 to zero point 0.6. Even it is not there. So since your product is only that they are not producing in anaerobic digestion process, cell mass production is very less. So we can assume the cell mass growth is negligible. In that case, we can epsilon p we can assume to be zero point 0.5, zero point 0.7. It is if not there. So you can easily find out y p by s. But when you calculate the y p by s, the unit of that is the gram of methane per gram of substrate utilized. And this substrate will be the organic. When you use the solid substrate, you have two different components. One is the volatile solids, another is the non-volatile solids. Now, question comes: what is the difference between the volatile solids and non-volatile solids? Suppose you take a solid material and dry it, and then you burn it in presence of oxygen. How you burn it? You keep it in the oven at 600 degrees centigrade for couple of minutes. Everything, all organic matter will be burned, and whatever material that remaining, we consider those are the oxide of the metals, and so that is considered as the non-volatile components. The volatile components of any kind of solid material usually we consider as the organic material, and non-volatile components we consider as a metallic residue that present in the particular solid residue. Now this ratio y p by s is the gram of methane produced per gram of organic substrate utilized. Am I right? Now your question is that how it can be converted into moles. So naturally, so if you know the molecular weight of the organic substance, so how you can find out the molecular weight of the organic substance? If you know the empirical formula, you can easily find out this molecular formula of the organic molecules. The so, so that is so by if you now you defined by your molecular weight of per gram carbon substrate, per carbon atom substrate. Now this is very important. Now when you prepared any kind of empirical formula, suppose your organic compounds is comprises of carbon, hydrogen, oxygen, any type of sulfur, nitrogen, or different type of compounds. So that, so mostly I can assume your if you consider any kind of lignocellulosic material, mostly it contains carbon, hydrogen, and oxygen. So CHN. Now, when we derive this compound, suppose I can give a very typical example. Suppose I am taking the example of glucose. What is the formula of glucose? C6H12O6. Am I right? So this is the formula of the glucose. But when you write in the stoichiometric equation, you have to write in as a per gram carbon atom. So how can do that? You divide by how many carbon atom is there? 6. So you divide by 6. Everything you divide by 6. Then what you will get? The formula will be CH2O. CH2 is the formula of the any kind of carbohydrate. Carbohydrate means the CH2O. So that is per gram carbon atom. So you have to find out what is the molecular weight of per gram carbon atom. Then you have to find out what is the molecular weight of per gram methane. Then if you just divide, suppose the product you have find out, suppose your ratio is coming 5 by 6. So 5 divided by the molecular weight of per gram methane. So carbon atom methane, that you can easily find out what is that. Carbon is the atomic weight is 12, hydrogen is 4, 12 plus 4 is 16. So you just use divided by 16, you will get the gram atom of that particular methane, and that is called product. And substrate will be similarly you find out the substrate. If it is CH2, you know carbon 12, H is 2, O is 16. So you can easily find out the molecular weight of that substrate. So you divide the amount of substrate by this molecular weight, then the gram atom of substrate. So Simple, you take the ratio, you will get, you can easily convert this into gram atom product per gram atom substrate. Am I right? So this might be your, and if you know that, then you will get the coefficient, the B coefficient that we have, that you can easily calculate. I think this was your question. So what we have written, that to evaluate the stoichiometric coefficient B, Y P by S can be expressed as mole-mole ratio. B can be calculated from the value of this Y P by S. Am I right? And then this is equal to P. This equation, the equation we have written, B equal to Y P by S, molecular weight of substrate by molecular weight of product. Because the product is there, the product will come at the denominator, and substrate is the numerator, substrate is the bottom. So it will go to the numerator, molecular weight of the substrate. From calculation of the stoichiometric coefficient of the product, both the formula can be used, but convert product yield can be calculated gram-gram ratio. This is how you can convert to gram-gram ratio. This is a very simple conversion process. You just put pen to it, and you can easily do it. So it is not a problem for you. We have given a typical example, that in case of Y by P by S equal to 0.176 gram of methane per gram of substrate, then you can write it. Suppose that that I have that is that. So what is the substrate, that molecular weight might be 30.6. So you have to multiply by 30.6 divided by 16, then you will get the this is 0.33. The actually this will not moles. This is a gram atom of moles. You can write moles of methane per mole of substrate, or you can write gram atom of of methane per gram atom of substrate. This is is in mole to mole, and that gram atom to gram atom you can easily convert it from the mass to mass. So this is a very simple conversion process. I hope you can do by yourself. Now, next question, that is Isita asks that what do you mean by competitive inhibition and non-competitive inhibition? Now, you know that first you should know what is called inhibitor. Inhibition means the retardation of the velocity of reaction. Inhibition doesn't mean the stop the reaction. Am I right? Inhibition means the retardation of the velocity of reaction. Now, there are three different type of inhibition is there. One is competitive, non-competitive, and uncompetitive, as far enzymatic reaction is concerned. Now, what is competitive inhibition? What is non-competitive inhibition? Now, suppose I told you the enzyme has the active site. Am I right? Now, how the reaction take place? When enzyme and substrate they interact, the substrate has to sit at the active site of the enzyme, and then it react and give the product. Am I right? Now, suppose and I told you that how the interaction take place. Interaction take place. The reason is that the configuration of the active site is something similar with the structure of the substrate. That is why the substrate can see that active sites of the enzyme. Now, suppose some organic molecule has similar structure, then what will happen? If that particular molecules present in the mixture, then it will compete with this particular substrate. That some cases, if that that particular compound seed, then it will not give any kind of product. But if a substrate seed, then and only it will give the product. Now, if that one particular side, if you have a competition, that for both for the inhibitor and the substrate, then usually we consider as a competitive inhibitor. Let me repeat it again. What I am saying, that enzyme has a active site. I have already explained at the beginning of my live session how active site formation takes place. And actives in the during the, and I told you that the proteins has the that has globular structure, and globular structure means that it is randomly folded, and randomly folding is due to the hydrogen bonding, and due to the randomly folding, the active site formation takes place, and the configuration of active site, if it is a imbalance with the configuration of the substrate, then it can sit there and give the product. But now the configuration of the active site is similar to the other than your substrate. Maybe some other compound is there, they have similar, but it is not a substrate. So with respect to that particular enzyme, it will not give the product. So this is called the competitive inhibitor. So your one active site, but two competitors are there. One is your substrate, another is your other than substrate. So then we consider as a competitive inhibitor. Now question comes, what do you mean by non-competitive inhibitor? Non-competitive inhibitor means that that suppose the enzyme is a how you define the protein? It's a protein basically is a polymer of amino acids. So it is a quite big amino acid. Suppose during the random folding, not necessarily that it will be having one particular site. It may develop the other site also. And it may so happen that some compound can sit other than the active sites of the enzyme, and then when you sit it there, and sit there, and also this substrate will sit at the active site. Now, when that means it forms the trimolecular complex. You have enzyme, you have substrate one side, you have inhibitor one side. This is called trimolecular complex. So in case of non-competitive inhibition, there is a formation of the trimolecular complex. So this has been explained very clearly in my presentation. So if you have any problem, then please consult book. There are so many books are available there, because but still I shall try to explain. This is that that here I have given the explanation like this: the presence of inhibitor in the reaction mixture can decrease the enzyme activity. So what I initially pointed out, that inhibitor means retardation of the velocity of reaction. And in case of enzymatic reaction, enzymatic activity is the velocity of reaction. Am I right? How you express the activity of the enzyme? The enzyme activity can be expressed in so many ways. In the moles of micromoles of substrate converted, or micromoles of product form per minute, per milliliter of enzyme solution, per milligram of enzymes like this, or protein. You can easily do that. The inhibition may result from the interaction between the inhibitor and the enzymes. Am I right? Or between the inhibitor and the substrate. It may be like this. In case of competitive inhibitor, that causes the inhibition both some extent to the molecular similarity with the substrate. As I pointed out, that the configuration of the active site is should be same as the substrate, so that it can sit there. Now, if the inhibitor has similar type of configuration, then so it will compete with the substrate, try to occupy the space, and then the activity of the enzyme will be reduced. And this allow a competition between the inhibitor and the substrate for enzymatic active site. And the competitive inhibition can be overcome by increasing the substrate concentration. Obviously, if you increase the substrate concentration, then the kind of the competition, that more substrate will get the opportunity to occupy the active site as compared to the inhibitor, and your enzyme activity will be more. In case of non-competitive inhibition, that inhibitor has the affinity to the free enzymes as well as enzyme substrate complex, because that as I pointed out, not only it binds with the free enzyme, but also it binds with the enzyme substrate complex, that is called trimolecular complex. However, the binding sites of the inhibitor is located away from the active site. This is other than the active site. So inhibitor does not bind at the active sites of the enzyme, and due to this, the binding of the inhibitor or enzyme doesn't affect the affinity of the substrate for enzyme. So that this is the non-competitive inhibition, means that indirectly it influences the activity of the active site, because by sitting at the other than active site, it influences the activity of the now in case of competitive inhibitor, you should remember, Vmax will remain constant, but your Km value will increase. What is Km value signifies? Km is the Michaelis Menten constant. Now, if Km value is more, what does this signify? More substrate is required to get a desired amount of product. Am I right? If Km value is less substrate is required to get the same amount of product. That is the significance. So, in the competitive inhibition, that your Vmax, the maximum velocity of reaction, that will remain constant, because but Km value increases. That means that more substrate is required. Okay, am I right? And in non-competitive inhibition, what is happening? Km value remain constant, but Vmax value decreases. So that happens in case of non-competitive inhibition. I hope this is the answer to your question. Next question that we have is the Damkohler number is same as the Thiel modulus, but both got the same ratio as the maximum reaction rate and maximum mass transfer. This question was asked by the Isita. So there's a very nice question, but let me tell you, the Damkohler number is kind of parameter which is largely used for the heterogeneous reaction kinetics. Damkohler number, actually it is the ratio of maximum velocity of reaction divided by maximum mass transfer. What is the maximum velocity of the reaction? Vmax. What is the maximum of rate of mass transfer? Is KL into SB. You know SB. What is SB? SB is the substrate concentration in the bulk of the fluid. So when we use the immobilized system, that what happens immobilized system. Suppose this is immobilized surface. In this immobilized surface, the enzyme is there here. So substrate is present there. This is the substrate. So this substrate will diffuse to the. It will go here. Am I right? Then and only then the reaction will take place. And this here you have the enzyme or the microorganism, whatever is there. And when it's diffused, that this is SB, the substrate concentration at the bulk, and this is SS, substrate concentration in the surface of the region. Now, what is the dragging force here? SB minus SS. Now, if the whole substrate is available on the surface of the enzyme, then that is the maximum diffusion takes place, because your KL into SB minus SS is the rate of mass transfer. When SS is equal to 0, then it will be then SB will be KL into SB will be the maximum mass transfer rate. So Damkohler number actually is the ratio of maximum reaction rate divided by maximum mass transfer rate. I hope you understand. While the Thiel model defined relationship between the reaction rate and the diffusion rate, not maximum. The reaction rate and the diffusion rate in porous catalyst or platelet with no mass transfer limitation. It is the ratio of reaction rate and the diffusion rate. I hope you will get the answer. Now, the next question is that maybe what is the role of the industrial enzyme, industrial strain? I think This might be the question by the student called Saksi. Uh, so you know that in industrial strain, um, and there are two type of microbial strains are there. One is called industrial strain, another we call wild strain. Am I right? Now, what is wild strain? Wild strain means all the microorganisms they are available in the soil. All the microorganisms. Suppose you take the soil and isolate a particular microorganism. That is a wild strain. So same strain that there organism. Suppose I work with the citric acid industry, and we produce citric acid from Aspergillus niger. The Aspergillus niger can be available any kind of citrus fruit. I can isolate the from a rotten citrus fruit. We can easily isolate the Aspergillus niger. When isolate the this that from the rotten citrus food, this organism we consider as a wild strain. But what is called industrial strain? Industrial strain means this organism is undergoes several treatment process. And what is the purpose of the treatment process? One important purpose is the genetical stability. What do you mean by genetical stability? Because every microorganism has a different generation. Because my industrial strain, every industry they operated by the help of industrial strain, and industrial strain they have to purchase, and the cost of the industrial strain is very high, maybe 1 lakh, 10 lakh, or 2 lakhs rupees like this. But in case of if you want to purchase any kind of microbial strain from the cultural collection center, it hardly costs you 1,000 to 2,000 rupees, not more than that. So so you see that the price difference. So why the price difference is there? But because a lot of the R&D work has been done for the development of the industrial strain, and one important purpose is the genetical stability. Why genetical stability? So that the different when the organism undergo different generation process, the genetic capability of the organism should not be changed. And if their genetical characteristics of the organism remain unaltered, then and only then you can get the same productivity. The industry when we run any kind of production process, they never compromise with the amount of product that is produced per day. Am I right? So so that is why genetical stability is very important. Another is the rapid growth. But growth rate is suppose two type of products is there. One is growth associated and then non-growth associated. If the growth associated is there, then rate of product formation is directly proportional to the rate of growth rate of the cell. Even suppose in case non-growth of associated product, rate of product formation depends on the microbial cell. But in the fermentation, in all the fermentation industry, they have both the inoculum vessel as well as the production fermenter. And what is the size of the inoculum vessel? Is 5 to 10% of the production fermenter. Am I right? 5 to 10% of the production fermenter. So, so suppose I work with citric acid industry, the capacity of our production fermenter was 200 cubic meter. So 5 to 10% is the what? It is 10 to 20 cubic meter. So our inoculum vessel's capacity was 14 cubic meter, 14, 1/4 cubic meter. So the 14 cubic meter in 40,000 liters. The 40,000 liters you cannot produce in the culture, you cannot produce in the lab. So you have to produce in the plant. So in the lab, you prepare the seed culture, you transfer aseptically to the inoculum vessel and produce the culture, and aseptically then you transfer to the production vessel. So that so in the when the organism grow in the inoculum vessel, then there also it should have rapid growth characteristics. And not only that, another in the production fermenter, one important factor is that product concentration. The suppose in the fermentation broth, if the product concentration is less, then the product purification cost will be very high. Then your cost of the productivity will increase. Now, if the concentration of product in the fermentation process is more, then your separation cost or purification cost will be less. Because that here I want to add that whatever chemicals is produced through the chemical process, but whatever chemicals we have, we are producing through the chemical, most of the chemicals we can produce through the biological process. But in practice, we can produce a limited number of chemicals through the biological process. Why? Because the reason is that the concentration of product is so less, our purification cost is very high. And since the purification cost is very high, that will influence the cost of product. Am I right? So this is the main factor. And another main factor is that this organism should have the capability to use the different type of substrate. Because suppose if the one organism can produce one particular substrate, initially it might be very cheaper, but after some time it will have, might be that when the when the that that raw material source people, they will find that we have lot of demands, then they will slowly they will increase the price to make the cost the price of the raw materials balance. You should always have the multiple choice of substrate, so that cost of the substrate will be little bit balanced. It will not change randomly. So the multiple use of the raw materials is also very important. Another is the high fermenting power, that is also is required. So these are the typical characteristics of the industrial strain. So I hope you understand that. Now another question asks about the this mu calculation, mu written by mistake. This is mu should be replaced by pi. Pi is pi is 3.14. You make the necessary correction. This is in case of air filter, one air filter problem we have written. So mu should be replaced. Mu is the should replace by pi, and pi is nothing but 22 by 7, which is equal to 3.14. So this is the cross section area you can easily find out by using pi r square. There is a cylindrical, if we use the cylindrical surface, the pi r square is the cross section area. So you can easily find out this, and where r is the radius of this. So that you can calculate the radius. From that you can calculate the radius. So this you make the corrections. Thank you for your question. So another is that nowadays we find the milk of brand Good Life, etc., with extended shelf life. And so, what is added to that milk? This is also a good question. But that let me tell you that milk is a good media for the growth of different pathogens. As for example, that you have Shigella, as for example, there's Mycobacterium, tuberculosis, the different type of pathogens that can grow in the milk very easily. And milk contain very high moisture content, so it is a very good media. And it as soon as an air contains all these contaminants, as soon as they come in contact with the milk, immediately they grow and they affect the milk quality. Now that is why the shelf life of the milk is not very long. Now your question is that some cases the milk life can be extended. Yes, it can be extended. Suppose if you do the sterilization of the milk, because two type of heating system is there. One is called sterilization, another is called pasteurization, and both processes are different. What is sterilization? Sterilization is considered the destruction or removal of the all contaminants. That again I am repeating, sterilization is defined as the destruction or the removal of all the contaminants present in the milk. And what is pasteurization? Pasteurization is the process through which you can remove all the pathogenic organisms. Now, what is pathogenic organism? The pathogenic organisms are those which are harmful for our system, which are harmful for our system. That is called pathogenic organisms. I hope you understand that. So so if you do the sterilization, I assume you kill all the microorganisms and you make a hermetically seal. What do you mean by hermetically seal? You seal in a manner you don't give any kind of opportunity to air come in contact with the liquid. Am I right? So you know that if then you can keep the milk for a longer period of time. So since sterilization you did usually taking for longer type heating as compared to pasteurization process, the energy consumption in the sterilization process is much high as compared to the pasteurization process. Not only that, since you are heating for longer period of time or you're putting more energy, the nutritional quality of the milk also will be lost. And so that is the major problem. Another issue is that if you use some kind of preservative. Now, most of the preservative they are not good for our health. So that is one of the important issue that we have. That also you have to take into account. Now, so that might be the reason how we can increase this. So now usually now a question arises: the milk, protein, or fat they are very good for human health. Now question comes that how we can preserve this milk, protein, and fat for longer period of time. So this we can preserve very easily by using a product called cheese. You know, Western market they're flooded with cheese because and cheese you can preserve for longer period of time. How cheese production take place through the process of first step is the card making process. After card making process, then they do the salting process through which the take out the whey, and then they cook the cooking. They pass it through the cooking process, which is done at different temperature, and different type of cheese are available. More than 500 different type of cheese are available in the world. So this is here during now during this card making process, the lactose that present in the milk that will be converted into lactic acid, and lactic acid acts as a preservative. And this due to the presence of lactic acid, we can and also moisture content is drastically reduced because you are taking out the whey. During the salting process, most of the water will go out. The water content in the cheese is much less as compared to the whole milk. This is how you can preserve the milk, protein, and fat in the form of cheese for longer period of time. So what we have trying to give the answer, the application of importance of lactic acid bacteria has been explained. Lactic acid bacteria is used as a preservative because not only that I mentioned during the yeast fermentation process addition of lactic acid help in preventing the contamination of growth, so by the putrefying bacteria by reducing the pH of the fermentation broth. And how moreover in the manufacture of pickle green olives, addition of lactic acid bacteria helps in acidifying the brine, high concentration of salt solution and reduce the risk of spoilage. And generally, milk is processed by heat treatment, which mostly include the pasteurization and sterilization technique. The milk with extended shelf life packing and TerraPack mostly involves the ultra high temperature processing to destroy the bacteria. That is exactly what I want to tell, that if you do the sterilization, if you ensure all the organisms are killed, then you can keep it for longer period of time. But when you do that, at the same time you have to compromise with the quality of the milk. So that is the main problem that we have. Now, the other some question has been asked in the Google form. One is Unup, and what he has asked that scope of industrial biotechnology after MSc in biotechnology and job after MSc, explanation of the industrial biotechnology core skill and knowledge about the various related aspects. Now, now the answer to this question I can give you that scope of industrial biotechnology is enormous because we have we have a lot of biochemical industries, lot of different pharmaceutical industries that largely throughout the world that is traded. Not only that, the biotechnology has the applicable not only in the medical sector, but also it is applicable in the food processing, what you call food biotechnology. It is applied in the environmental sector. It has a use in some production sector, because different I have discussed different oxychemical production processes. So this expertise, what you develop, you can utilize by any of these industries. But you know that your theoretical, this is your theoretical knowledge, and when you work with the industry, then we'll make a bridge between the theory and the practical. This is how you can do that. So what I suggest, that you can undergo some kind of training program in some industry like Biocon, Reddy's Lab, and other things, to develop some kind of industrial experience, so that the industry will be interested to you, or different biological organization, the biotechnological organization will be interested you to take you. So one thing I want to highlight here, that in case of biotechnological the student, not only your knowledge is important, but also your expertise also equally important. How much practical exposure you have, that also plays very important role. I hope you understand that. Now, Isita asked some question that inhibitor kinetics, how can we nullify the inhibition caused due to competitive and non-competitive inhibitor? That that already during my presentation I tried to point out that in case of competitive inhibition, that no that effect will be little bit reduced if you keep on increasing the substrate concentration. Am I right? At infinite substrate concentration, V tends to Vmax. That is the one of the approach that we have. And non-competitive inhibition, that that Vmax is reduced, so it is very difficult to compromise. So this actually, this particular inhibition, the competitive inhibitor, are used for the development of different drugs. So you should be knowing that, because if you go through the good biochemistry book, you will find how this competitive and non-competitive inhibitor are largely used for for making some kind of medicine in our system. So that is the answer that we have. So with that, I come to the end of this whatever question I have received so far. Now I shall have to go to the chat box. I don't know where to get the chat box. Hello,
Yes, sir.
chat box. Do you have any question?
Sir, one question has been asked by Miss Alvina. She has asked that can secondary metabolites be synthesized by using continuous culture system or not?
Okay, this is a very good question that has been asked. That 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 two type of metabolites we have. One is called primary metabolites, another is secondary metabolites. Am I right? Now, primary metabolites, that is usually we consider, the examples are, one example I can give you, that your acetic acid, lactic acid, all are primary metabolites, ethanol, all are primary metabolites. But secondary metabolites, we have like most of the antibiotics are the secondary metabolites. Now, secondary metabolites formation usually take place in case of stationary phase. In the stationary phase, if you look at in the stationary phase, that rate of product formation is proportional to the concentration of the cells. Am I right? And let us take the example of penicillin fermentation process. Penicillin fermentation process, penicillin formation takes place at the stationary phase. Now, how you define the stationary phase? Stationary phase is defined as the starvation phase. And what is starvation phase? Where you have lack of nutrient. Am I right? Where there you have lack of nutrient. So what we can do, we can extend the log, the stationary phase, by putting little the nutrient to the media, and just to allow the organism to survive, so that we can get the more product in the system. So in that way, in a semi-continuous way, we can operate the system, but continuous way it will be very difficult to operate the system. Okay. Any other question, Harshita?
No, sir. No, sir. That's all with the questions.
So anyhow, if there is no question, I can stop my presentation here. And thank you for your participation in my program. I hope this experience will surely help you for your future development. And in case you have any question, please ask the question in the forum. That we try to give the answer. And with this, I wish you all the students wish you all the best, and with lot of success, lot of happiness in your life. Thank you very much. Hello.
Yes, sir.
हेलो, हो गया ना हम लोग का? ना अभी भी
Yes, sir.
कंटिन्यू? Okay,
Sir.
because no question is there, so I can stop. Okay, anybody from CET? Hello.
হ্যাঁ স্যার।
তো এখন বন্ধ করে দিচ্ছি, ঠিক আছে?
ওকে স্যার, ওকে, নো প্রবলেম।
Okay.
হুম।
Okay. Thank you.